What happens when a building ignores wind load? Welcome back to Blueprint to Reality, the channel where invisible forces become visible engineering realities. Wind is something we feel every day. But in structural engineering, wind is not just air in motion. It is a powerful, dynamic load capable of bending, twisting, and even destroying buildings. Today we answer a critical question. What happens when a building ignores wind load? Introduction. Wind has brought down bridges, cracked skyscrapers, and caused buildings to sway uncontrollably. Unlike gravity, wind changes direction, varies in intensity, acts dynamically over time. When wind load is underestimated or ignored, failure does not always happen instantly. Sometimes it begins with vibration, discomfort, cracking, and long-term damage. In this video we'll explore how wind interacts with buildings, what engineers must consider in wind design, what happens when wind effects are ignored, real-world failures caused by wind, and how modern engineering prevents these disasters. 1. How wind acts on buildings. When wind strikes a building, it does more than push. Wind pressure and suction. Windward side experiences positive pressure, leeward side experiences suction, roofs experience uplift forces. These forces try to slide the building, overturn it, tear components away. Dynamic effects. Wind causes fluctuating pressures, vortex, shedding, oscillations, and vibrations. Tall and slender buildings are especially vulnerable. 2. Why wind load is not a simple force. Many failures occur because wind is treated as a static load. In reality, wind speed increases with height, gusts create peak loads, resonance can amplify motion. Ignoring these effects leads to excessive sway, fatigue in structural elements, cracking of non-structural components. Comfort and safety are both compromised. 3. Common engineering mistakes related to wind load. Underestimating wind speed. Using outdated data or ignoring local terrain effects leads to unsafe designs. Ignoring aerodynamic shape. Flat, sharp-edged buildings attract turbulent flow and higher wind forces. Insufficient lateral stiffness. Lack of shear walls, bracing, or rigid cores causes excessive drift. Neglecting serviceability. Even if a building doesn't collapse, occupants may feel motion sickness or fear. 4. Real-world failures caused by wind effects. Tacoma Narrows Bridge demonstrated that wind can induce catastrophic oscillations. Citicorp Center, 1978. Discovered design flaw related to quartering winds that nearly caused failure. Residential and industrial roof failures. Many roofs fail due to uplift during storms and cyclones. These failures highlight what happens when wind behavior is misunderstood. 5. Structural consequences of ignoring wind load. Ignoring wind load can cause excessive lateral drift, cracking of beams and columns, failure of cladding and glass panels, progressive structural damage, eventual collapse in extreme cases. The damage may start small but grows over time. 6. Non-structural damage and human impact. Wind doesn't just affect structure. Causes: glass breakage, falling facade elements, elevator malfunction, occupant discomfort and panic. Many buildings are evacuated not because they collapse, but because they become uninhabitable. 7. How modern engineering controls wind effects. Wind load codes and standards. Modern codes include gust factors, terrain categories, importance factors, aerodynamic design. Rounded corners, setbacks, and openings reduce wind forces. Structural systems. Shear walls, braced frames, trigger systems. Damping systems. Tuned mass dampers, viscous dampers, sloshing tanks. These systems absorb and reduce motion. 8. Wind tunnel testing and digital simulation. For tall and complex buildings, wind tunnel testing is essential. Computational fluid dynamics, CFD, predicts flow patterns, multiple wind directions are analyzed. Ignoring these tools increases risk significantly. Lessons for engineers and designers. Wind load teaches engineers Nature cannot be simplified. Dynamic behavior matters. Safety includes comfort and durability. Small assumptions can cause big failures. Designing for wind is not optional. It's fundamental. Conclusion. When a building ignores wind load, it doesn't just fight the wind. It invites failure. From vibration to cracking, from discomfort to collapse, wind exposes every weakness in a structure. Great engineering respects nature's forces and designs structures that move safely, not dangerously. If this video changed the way you think about wind in buildings, like, share, and subscribe to Blueprint to Reality. Comment below. Which invisible force should we break down next? Wind, earthquakes, or temperature effects? At Blueprint to Reality, we make hidden forces visible through engineering. See you in the next video.